Okay, this tutorial is going to look at solving quadratic equations with the square root property. And this square root property is quite simple. It basically states that if you have, say, anything equaling x squared, say if x squared equals, let's say, b, then you could square root both sides, and x would equal plus or minus b. Remembering that when you have a square root, 4 times 4, for example, would be 16 when we square 4. Also, you have to remember that 16 is also negative 4 times negative 4. So be careful that you don't forget about the plus or minus property of the square root property. So we're going to use this square root property to solve a few examples here. And there are 3 or 4 basic types of examples. The first one here I'm going to show you is just isolating the squared term by itself first. So that's what you do, is you isolate this. So add 3 to both sides. And here we have 4x squared equals 36. Oh, well, we can divide by 4 to get x squared equals 9. And then we square root both sides. So root both. So if I root the x squared, that becomes x. And the root of 9, the square root of 9 can equal plus or minus 3. Remembering that negative 3 times negative 3 is also 9. Okay, in our second example here, we have a similar situation, but we have a binomial squared. So what you do there is you isolate the binomial by itself, the binomial squared by itself. So add 1 to both sides. And you get 3x squared, or 3x, pardon me, minus 4 all squared is equal to 16. Once you have that binomial squared isolated, you can then square root both sides. So the square root of that would be 3x minus 4 is equal to plus or minus 4. So there's 2 possible answers here. You have 3x minus 4 is equal to positive 4, or 3x minus 4 is equal to negative 4. And then you just solve for x in each. So add 4 to both sides in this one. And in here, add 4 to both sides as well. So this is going to put 3x is equal to 8 here, or 3x is equal to 0. So that means that x can equal 8/3, or possibly x can equal 0. Okay, so that's our possible 2 examples there that we have. Now I'm going to flip over my page and do another example that would use the fractions that we've had. Now there are also examples that sometimes use brackets as well, but I'm going to do one that uses fractions, and hopefully this time I'll remember. If you remember last tutorial, I forgot to put in the common denominator for the last term, and I had to stick it in there after a step or 2. This time it's a simpler example. So our common denominator that we're going to multiply both terms by is 5 times 2x minus 3. So that's what we're going to do, multiply by a common denominator, or a common term, I guess, in the denominator. So this would be 2a plus 3 over 5 multiplied by both of those terms, 5 times 2a minus 3. Remember 2a minus 3 because that's what's on the bottom here, those 2. And that's going to equal 3 over this 2a minus 3 times our same thing, 5 times 2a minus 3. And then we can work it out. Okay, so if I work this out, these 5 cancels. So we've got 2a plus 3 multiplied by 2a minus 3. And that's going to equal, these 2 things cancel out and gives us 15 here. So working this out, we'll just work it out by expanding using FOIL. So this will be 4a squared plus 6a minus 6a minus 9 equals 15. So these things are canceling out. So we've got 4a squared minus 9 on one side equaling 15. So then we go back to the square root principle. We have to isolate the 4a squared by itself. So add 9 to both sides. 4a squared is going to equal 24. Okay, then we can take out a common factor of dividing by 4. So a squared is going to equal, if you divide that by 4, 6. And then just take the square root of both sides. So make sure I'm still writing in the view pad. Good. So that would mean a is equal to plus or minus the root of 6. And we can leave it in root form like that. Now that's as simple as that would be. So there's our answer. Now the book puts solution sets. They often will go solution set and they'll have brackets like this. But you can do that if you wish, or you can leave it in this form. I accept both answers on exams and stuff like that, so no problem there. So in our next section, our next tutorial, we'll be looking at solving quadratic equations by completing the square